Oh, we are live. Okay, nice. Um, I don't have the. Give me a sec. All right, I guess we good. Um, hello, my name is SP. I'm a protocol engineer for Waku. Um, and today's presentation topic is the service marketplace. Um, yes, hello everyone. I was not sure if my colleagues were in the chat, but they are, so cool. Um, yeah, so um, service marketplace. Um, we're gonna start the presentation with a quick introduction of what and why a marketplace. Um, then we're gonna go into all the problems that we need to address before we have a working marketplace. So payments, abuse prevention, discovery, load balancing. Then I'm gonna quickly present some proof of concept that we developed already, and then do a brief ecosystem overview of all the other projects that are trying to do something similar. And then lastly, it's going to be kind of a roadmap of next step on our road to a fully working service marketplace. Um, yes. Next slide. Right. So what and why a marketplace? In a Waku network, most device contribute and consume services. Usually, phones and light devices and even other nodes can join the network without participating. Really, and we need a way to have them consume a service, but uh, contribute in some way, and it's probably going to be financially. So to do that, we need to build some kind of decentralized infrastructure for application developers, because people are not going to provide service for free. It's kind of it happens, but we can't rely on that. So we need to really build something that is incentivized. And also for app developers, it would be a really great experience to not have to deal with infrastructure. So they would just build their apps and then assume that some decentralized infrastructure is going to exist to serve their users. Um, and another thing would be potential revenue generation for the Waku project, because yeah, developers that build protocols, they need to eat too. So please, we need some revenue. Um, okay, now we have the first problem we need to fix before we have a working marketplace. This is the payment. How do you have phones or other light devices pay for services? So there's many different ways of doing that. A lot of projects in the ecosystem use tokenomic systems, so everything's happen on a blockchain. There's smart contracts involved in that. Usually buy some tokens, and then the service providers are rewarded with tokens. There's maybe inflation of the tokens and other systems like that. So there's an economic loop that happens, and everybody's incentivized to do their job properly. There's also probabilistic micropayments, which is, it's not as complex as building an entire tokenomic system. It's mostly to transfer value from the customer to the providers of the services in a way that's more scalable than just a blockchain transaction. And also the user experience would be better because you don't have to sign as many transactions. Yeah, just overall more scale, better UX. And this can be paired with gasless transaction. We have in the work a new L2, and then we could do gasless transaction for micropayments. That could be a way to address the payment problem. And then to wrap this, there would be this authorization abstraction, because currently the Waku protocols that needs incentivization, they're not really built for, there's no kind of a gatekeeping built in. So you can't distinguish the user that requests services. So if we could build like some kind of authorization, not protocol per se, but maybe modifying protocols for to handle authorization, that would be great. It would also enable the use case of paid for services, free services, or services that are gated with other methods, like maybe some kind of zero knowledge proof that you submit, and then that's enough to be authorized to access a service. Something like that. Another problem we have to address is abuse prevention. Any economic system is going to attract, I guess, cheaters and fraudsters. So we have to protect customers. So if you buy some service, some Waku service, you need to be protected in some way to actually be sure that the service is rendered. But there's also on the flip side, providers need also to be protected with some mechanism so that when they provide service, they actually receive compensation for it. So how this mechanism is going to work, can be varied. Some other projects in the ecosystem, they use service quality assurance. So basically, a provider is tested for the quality of the service they provide. Usually, or it would be best if they don't know when they're tested. And then they're rated for the quality of their service, and then somehow penalized or rewarded based on the rating that they receive. There's also some verifiable services. That's a bit more tricky because a lot of different services you can't really verify. For example, if you have a bandwidth sharing use case, you can't really verify that bandwidth has been shared, so that's not verifiable. But in some cases, you could verify that the service was rendered, and then if it was not, you can issue some challenge and penalize providers that don't actually deliver the service. And then there's a reputation. So if we build a reputation system for providers, that could prevent abuse in the long term. So to prevent providers from usually cheating more than once, basically, because they would accrue bad reputation via rating, some kind of rating system. And then for customers, it's a bit simpler, because if you just ask payment for services upfront, but you can't be really cheated in that way. So it's a bit simpler. Yes. Okay. Next slide. Discovery. So the service marketplace, there would be obviously many services. In the Waku network, there's many shards, many different protocols, and there would hopefully be many service providers. So the first problem of discovery is that if you're searching for a specific provider for a specific shard, a specific protocol, it becomes really difficult to find those specific providers, just because of the lot of permutation possible in the search space. And then currently the Waku network use disk v5, which is a distributed hash tables that only do random walks. So you just randomly discover nodes in the network. It's quite resilient to attacks, but it's really inefficient for actually searching very specific nodes. There are many different possible solutions to those kind of problems. There's a way to kind of split Cademelia DHTs. So for example, they would be, for the same node, you would have one DHT for one protocol, or one DHT for one Waku shard. And then a node would just be part of many sub DHTs at the same time. So that could improve the efficiency of the random walk that we do to find nodes. But it doesn't really fix the problem. It just makes it more manageable. Then we could also go another direction, which is implement the disk v5 topic advertisement. It's a research paper. So basically, you would use the disk v5 DHT in a different way. Nodes would choose to advertise specific services, and then searching for specific services would also be much quicker. So the research paper goes into details about how to do that. As far as I know, it's not really implemented anywhere, but it's one avenue to explore. And there's this idea of a decentralized provider database. So in this case, it would be kind of just a plain database that's synchronized across nodes, and this database would have a list of providers with all the shards they're supporting, the protocols they're supporting, maybe the price, maybe like all the information you would need to make an informed decision as to which provider you want to use. Nodes in the network would synchronize this database. And yeah, that's maybe a less fleshed out idea, but could also be good enough of a solution. All right, next problem would be load balancing. Maybe a smaller problem than the other three. If we get to a stage where the service marketplace is successful enough to have providers that are too successful, which would be a good problem to have, we would have to think of a mechanism to prioritize certain providers over others. A lot of other projects used tokenomic system. So the providers stake tokens, and then the stake token, the amounts of token staked is kind of a ranking system of who gets more requests. So it acts as a load balancing mechanism. There's another idea about just having a smart contract where providers can kind of advertise on it by buying a advertisement slot and paying a arbiter tax on it. And you could also just leave it to the application. So the application could devise local ways to load balance just by picking providers in a very specific way for their application. It's kind of vague how they would do that, but depending on the application, that's mostly possible to do that too, as well. All right. So the proof of concept we have been working on is for the light push protocol. So it's a small proof of concept of you paying for pushing messages. So what we have right now is basically you submit a transaction ID, the transaction is verified, and then the customer keeps a local reputation of the provider they use. Basically, do you actually get the service rendered? Yes, thumbs up, and if no, then thumbs down. So we keep it simple for now. You have the QR codes, the GitHub PR. You can check it out. Yeah, so that was the first step into the road to a Waku service marketplace. There's gonna be many other steps because other protocols are maybe more tricky to implement incentivization for. But yeah, that was the first step. Okay, yes. So there's many other projects in the ecosystem that kind of have a marketplace. So to name a few, Huddle, LivePeer, the NIM MixNet, the Orchid VPN. I added QR codes to their white papers. Brief overview. So Huddle, they're doing they want to do WebRTC infrastructure. So basically, they're selling bandwidth, which is a service that you can't really verify that the service was rendered. So they use a kind of a quality assurance mechanism to prevent abuse. They usually test providers, and then they keep the result of those tests in the smart contracts. And they have a tokenomic system that reward providers based on the quality assurance mechanism output. And then the consumer, they just buy tokens, and they can pay for the bandwidth they use. And then LivePeer is a transcoding, so video transcoding network. You can pay nodes to transcode your video if you do live streaming. exactly what we're doing right now, I guess. They have a tokenomic system with nodes that do load balancing. There are other nodes that do the actual providing of the transcoding that happens on big machine with beefy GPUs, and it's all staked tokens, and then you buy the token, you can pay for your services, and then to prevent abuse, they have the basically verify that segments of video were actually transcoded correctly, and if not, then the stake tokens are slashed, basically. Then we have the NIM mixnet, which we all love. They basically sell bandwidth, but for the mixnet itself, they use similar quality assurance mechanism. So they test mixed nodes, and then similar mechanism as the other projects. We have also the Orchid VPN. Again, they sell bandwidth, but they use what they call probabilistic nanopayments. It's the same mechanism as the micro. They just change the name, micro nano. Anyway, so basically, you put some fund in the smart contracts, and then you can generate tickets. That's your micropayment, which happen off chains, and then you send those tickets when you use the bandwidth of the VPN, and the provider of the bandwidth, they redeem the tickets. Most tickets are not winning tickets. That's where the probabilistic part comes in. But then when they get a winning ticket, then they redeem on chain. So I invite you to check out their white paper. It's all very interesting mechanism they use. And now the roadmap. So what we propose to do next is design and implement this, what I spoke before, the authorization abstraction for protocols. Just to be able to have a way to gatekeep the protocol access, either for just give the protocols for protocol access for free, or payment, or some other access token. So if we add the abstraction to handle these cases, I think it would be very useful. So the abstraction needs to be defined and implemented. And then researching and implementing probabilistic micropayments, it would be very useful. Like I said, it kind of works with any blockchains, any smart contract platform. The scalability is improved because you don't have to do as many transactions on chain. I believe the user experience would be better because you don't have to sign and use as many transactions as you previously. And it would probably be useful in many cases where you have to do payment, which I'm sure we're going to need. That's why that would be on the roadmap. So in steps after that would have to be decided. It's still many problems to study and try to find solution to. Here we have QR codes for VAC, the VAC forum. So many discussion on every topic I talked about. So just scan and read, and then comment, see what you think, contribute to the discussion. I'm done. Thank you. Questions? All right. Regarding service discovery, does it make sense to have a semi-centralized mapping of service to list of bootstrap nodes? Does it make sense to have a semi-centralized mapping of service to list of bootstrap nodes? So I'm not sure what you mean exactly, but yes, we could decide to start with with kind of a centralized registry of services. But I would argue that we need also a good plan to decentralize it, because it's not going to be good enough for long. But at first, yeah, one of the discovery solution was actually design a decentralized database, and in that case, you could start with just one node, so you would design this centralized database, but you would have only one node, just to make sure that we can test it, make sure it works great, and then you can have many nodes that sync with each other. And on this topic of bootstrap nodes, we could make different bootstrap node connect the light devices to some specific other nodes that might provide the service you need. So, for example, there would be bootstrap node for specific Waku shards, and then other bootstrap node for specific protocols. If you, I know, if I imagine if you know. Yes. So the authorization, it's very broad. So there are different use cases where the user of the system are not the consumer. So say you're using an app on your phone, the developer of the app would be the consumer of the service. You would be the one to pay, but the user needs to provide some kind of authorization to the service provider, because otherwise you don't want to identify them, because that's a private. So you have to authorize your user in some way, which is privacy preserving, so probably some kind of zero knowledge proof, which, and in that case, that's not a payment. So this authorization abstraction that I talked about would be the kind of the abstraction. So there would be the protocol, the authorization, and then the users, which may also be the payers, but not necessarily. But yeah, in that case, the abuse prevention would be via the pre-existing authorization. But the abuse prevention is mostly between the actual consumer, not the consumer, but the consumer of the service. Consumer in the sense that the one who's paying, not necessarily the user. Maybe my terminology it's not great, but the user is the one who's used it. The consumer is the one who's pay for it. I guess the payer. Yeah. I hope I answered the question. Any other question?
Looks like that's it for questions.
All right, so we wrapping up, right?
Unless you have anything else, yeah. Good presentation.
Okay, thank you. Thanks, everyone. Bye-bye.